Here we go. We have a question, shortest path in undirected graph. You have given a undirected graph in the form of edges having unit weight of the edges means every edge weight only 1 unit. Find the shortest path from source to all vertices, and if it is unreachable, to reach any vertex we have to return -1 for that vertex. Suppose we have 9 vertex and 10 edges. So here is the edges graph, here is the edges, and we have a graph here. Starting from the source node, if every edge weight is 1, so we have to find the distance to all the vertices starting from the source vertex. So in this source vertex distance is 0, and every other distance, suppose 1 distance is 1, then 2 distance is 2, 3 1, 4 2, 5 3, then 6 3, 7 4, and 8 4. We have to find the shortest path, and in this case 2 is not reachable, so we have to fill -1. So at first sight, if you look this question and you know a algorithm called Dijkstra algorithm, so at first sight it looks like we have to apply Dijkstra algorithm, but in this the edges weight is always 1, every edge weight is 1, so we can somehow optimize this. So let's build the approach. We have a graph and we have a source is 0, and we have to fill the minimum distance. Initially every cell contains maximum value, and starting from the source vertex its distance is 0, and every other cell value is maximum. So we start from this vertex. So we have a queue of integer only. We don't require integer array or priority queue. So on starting, we have this distance as 0, and on queue we have vertices. So starting from 0 vertex, we pop out this vertex and we find its neighbor vertices. Its neighbor vertices are 1 and 3. So now we have 1 and 3. So its distance, the 0 distance is 0, and 1 distance is +1 to the previous vertex. So 1 distance is 1 and 3 distance is also 1. Next element is 1. 1 neighbors are 0 and 2. But if we are at here 1, so its value is 1. The 1 vertex distance is 1. So if we try to go 0 again, the 0 distance is 2 now, which is greater than the minimum distance. So we will not update it. Its next neighbor is 2. So 2, the initial value of 2 is maximum, and we are reaching from 1. 1 distance is 1. So if we try to reach 2, its distance is 2 now. So which is minimum. So we fill 2 and we add 2. That's it. It's time for 3. Starting from 3, if we try to go backwards, so its distance is 2, which is greater than the initially filled value. So we will not update it. We will go to its next vertex. Its next vertex is 4. So 4 distance is 2. 4 distance is 2 because third distance is 1. So if we try to go to its next vertex, its value will be +1 to the previous vertex. So its value is 2. I hope you got the point now. So if we have second, then we don't go upwards again. Next we have value 6. So 2, 2 cell value plus 1, its value is 3. Next we have 4 and we go to 5. 4 value is 2, so 5 value is 3. Next we have, uh, actually I have to add 5. Next value is 6. So starting from 6, if I try to go here, here and here, so 7 value value is maximum. So I add 6 plus 1. So 6 value is 3. Here the value is 4. Same goes for 8 and for 5. For 5 the value will be 4, which is greater than the field value. So we will not update it. Next we have 5. From 5, if I try to go 6, if I try to go 6, then 6 value will be 4, which is greater than the initially filled value. So we will not go there. So that's how we will approach this question. And after that, there are there are some vertices which are uh, unreachable. So its value is maximum. We don't want maximum. If the value is unreachable, we will change it to -1. So that's how this algorithm will work. Let's code this. First, we have to convert this edges into a graph. So we have n vertices. So I am adding an array list into an list. Then we have to iterate in edges. So this is an undirected graph. So we have a vertex uh, from u to v and v to u. Not vertex, it's an edge. My bad. So then we have to make an array. Its initial value is maximum. Then source value is 0. Then we have to add this value into q. This is a vertex. Then we have to iterate, pop out the current value and its distance. Distance is present in the answer array. Then we have to iterate to its neighbors. If neighbor value is greater, so we will update it. So update your neighbor value with the distance plus 1, because we are moving from nodes to its neighbor. Then add it into a queue. So after this, we have to again do an iteration, and if the value is maximum in this case, so we have to fill -1 and at the end return our answer. Let's submit this, and in between let's talk about time and space complexity. Here we are iterating in edges, then we are iterating n, and here we are iterating a vertex only one time. So we have a time complexity n plus e. This is the edges, and we are iterating a edges only one time. So its time complexity is n plus e. And space complexity, we have a queue which contains all the nodes. So its value is order of n. This thing we have to take a list, a recency list. Then we also have a answer array. This is the thing that we have to return. So its overall time complexity is order of n only. And if you like this video, click on the like button and subscribe button is highly appreciated. And thank you all for watching.